Okay, this is the video lesson for concept 39. It's very important that we pay close attention starting with this concept, because we start building foundational knowledge to getting into our trigonometry. This unit is the intro to trigonometry, so it's very, very important. You guys know I've emphasized particular units throughout the school year that are just key for moving forward in Math 3, Pre-Cal, and so on. So this is one of those. What we have here is the 45, 45, 90 special right triangle. 45, 45, 90 pertains to the two angles inside the triangle. So I have 45 degrees, and a 90 here. They add up to 180, of course. If you recall, we have my post-it notes. If you recall from our previous units, two things you have to recall actually. That is, all right triangles, you can use the Pythagorean theorem to solve for the sides, right? A squared plus b squared equals c squared. And the other thing you have to recall, so towards the end of our unit on similar triangles, we did properties of isosceles triangles. These were triangles that were given where two sides were equal, and if you remember, because the two sides were equal, you were able to conclude that the angles that were opposite to those sides were also equal. So angle C was equal to angle B. One thing, you can also work backwards. So if you know that angle C is equal to angle B, you can say that the opposite sides of those angles are also equal. So these are the two things you have to recall for this concept here and this unit in general. So the 45, 45, 90 triangle, here are the two angles that are 45 degrees. Therefore, the two opposite sides, so that one to that one, this one to this one, would have to be equal. So I call those x. So then the legs are x. My hypotenuse is x square root of 2. And then how would I solve that? You would just use Pythagorean theorem. Okay, so we're going to show this for this one. So x squared plus x squared is equal to c squared. I'm calling this one c for now. And then x squared plus x squared would be 2x squared. That's equal to c squared. And then to solve for c, I would take the square root. So I get c is equal to square root of 2x squared. So I can split these up, right? We've done that before, and we're doing that now, right? On simplifying radical expressions. The square root of x squared, the exponent and the square root cancel, and then square root of 2, I can't do anything to it, so I get x square root of 2 is equal to c. So that's where this guy comes from. So my hypotenuse is x square root of 2. So then what is this? Every single right triangle that has a 45, 45, 90 triangle can be generalized knowing that the two legs are equal and the hypotenuse will be x square root of 2. This is essentially a shortcut so that you don't have to be taking the Pythagorean theorem all the time for this particular special right triangle. So here are some examples. Let me cover some of these because I don't want to show them yet. Okay, so number one, I have a 45 and a 90. The other one has to be 45 degrees, so I've labeled it 45 degrees. And I can therefore say, because these two are 45 degrees, the opposite sides are therefore equal. So if this one's 8, this one is also 8. So x is 8. My hypotenuse would be across here in blue is, and I'm just going to plug into my generalization I have up here. So if x is 8, if these two are 8, so 8 and 8, The hypotenuse is whatever these are, the x, right, square root of 2. So in this case it's 8. So then my hypotenuse is 8 square root of 2. You can take the Pythagorean theorem here to verify that this one is 8 square root of 2, and I guarantee you if you simplify correctly you're going to get this. So that's all there is to it. Number 2, I have 45 and 90 given, so then the other one again has to be 45. So therefore these two sides are equal. This one was given to be 25, therefore this one up here has to be also 25. So then the hypotenuse, this side here, has to be whatever these two legs are with times square root of 2. So it's 25 square root of 2. The only confusing thing about this would be just the way the handout has the sides labeled. It's not entirely consistent, so be careful what's x and what's y. So again, the two legs are 25, therefore my hypotenuse is 25 square root of 2. The last one here, I have a 45, 45, 90. Now, there's something particular about this triangle here. You were not given what one of the legs were. Instead, you were given the hypotenuse. Okay? Now, because the hypotenuse was given, we also know that the hypotenuse for all 45, 45, 90 triangles is x square root of 2. So then what I did was, I set that expression up so I can solve for x. X square root of 2 is equal to 19, because that's my hypotenuse. And then I divided both sides by square root of 2, so I got that x is equal to 19 over square root of 2. There's a problem here though. We do not express values with a radical in the denominator. Okay? We can't do this. So we have to rewrite it so that we get rid of the square root. What do? We multiply top and bottom, okay, numerator and denominator, by square root of 2. So 19 times square root of 2, square root of 2 times square root of 2. And recall that square root of 2 times square root of 2 is square root of 4. Square root of 4 is a perfect square, so you get 2. For the numerator, you're just going to get 19 square root of 2. And there's nothing you can do from there, so then that's it, you're done here. So then the two legs are equal again. So these are equal, right? X, and x. So then I got 19 square root of 2 over 2 here, and 19 square root of 2 over 2 here. So then that's my x and y. The other special right triangle is the 30, 60, 90. Okay, 30, 60, 90 degrees. So 30 degrees, 60 degrees, 90 degrees. The shorter leg, I'm reading here this box, the shorter leg is always opposite the 30-degree angle, and the longer leg is always opposite the 60-degree angle. Therefore, here's 30 degrees, my blue. Okay, this guy here is my shortest leg. I call him X. This guy here in red, okay, this is the longer leg, opposite from 60 degrees. So I got x square root of 3. And then finally, my hypotenuse, I'm out of colors here, but my hypotenuse would be across. Let's see if I can find a color. My hypotenuse would be across, in purple here, the 90 degrees, and then that's going to be 2x, 2 times x. So just to recap, x is across from the smallest angle, 30. X square root of 3 is across the 60-degree angle, and then finally the hypotenuse is across the 90-degree angle, 2x. So same thing like we did before, we're just kind of just identifying what's what and plugging into this general model. So let's look at this one here, this number 4. I have 60 and 90 given, so then the other angle has to be 30 degrees. Opposite to the 30-degree angle given here is 5. So 5 is my smallest leg. So 5 is this guy here. Right away I can find my hypotenuse because I know that the hypotenuse will be twice the smallest leg. So 2 times whatever this guy is. Right here he's 5. So then therefore my hypotenuse here would be 2 times the smallest leg, 2 times 5, which is 10. So then y, right, y is 10 right here. X is this guy here, opposite of the 60-degree angle, right there. And again, this side that would be opposite to the, this side that would be opposite to the 60-degree angle is x square root of 3. X being the smallest, the length of the smallest side, we know it's 5, so therefore this one is 5 square root of 3. And that's it. The next one, I have, again, a 30, 60, 90. So, and I'm given, let me see, I'm given the smallest leg. So that would be 14. Okay, so right away I can find what the hypotenuse is, because the hypotenuse is going to be twice the smallest leg, 14 times 2. So that's where this 28 comes from. Okay, so again I have 2 times 14, which is equal to 28. Opposite the 60 degree, it's going to be the length of the shortest leg times square root of 3. So it's 14, so then this guy is going to be 14 square root of 3. Number 6, I have this here. I have a 30, 60, 90 triangle. So, and this time I'm given the side that's opposite to the 90, so I'm given the hypotenuse in this case. Now, I know that the hypotenuse is 2 times the smallest side, 2x. So 2x is equal to 32, and I can solve for what x is, the smallest side, so 16. So then that means that the smallest side, right, opposite of the 30-degree angle, oops, let me make this darker, okay, it's going to be 16, half the hypotenuse. Because 16 times 2 is 32, it should be double, right, based on this. So then finally, opposite to the 60-degree angle, it's going to be 16 square root of 3, the smallest side times square root of 3. So that's this one here. So I get 16 square root, whoops, 16 square root of 3 there. Okay. Next one, number 7, I have a 30, 60, 90, and I'm given the hypotenuse again. So I can take the hypotenuse, and I know it's 2x, so 2x is equal to 46. Solve for x, I get 23. So then the opposite side to the opposite side to the 30 degree angle is half the hypotenuse, 23. And finally, opposite to the 60-degree angle, it's going to be the shortest side times square root of 3. So 23 square root of 3. That's that one there. Next one here. Oops. Okay. So I'm given the side that is opposite to the 60-degree angle, 20. I know that the side opposite to the 60 degrees should be x square root of 3. So I can use that information to solve for x. So x square root of 3 is equal to 20. I divide both sides by square root of 3, and I get that x is equal to 20 over square root of 3. So I have that so far. Now recall that I don't want to express numbers where, or values where, the denominator is a square root. So I would multiply the top and bottom by what's in the denominator, the root of the denominator. So I multiply top and bottom by square root of 3. Square root of 3 times square root of 3 is square root of 9, and then the square root of 9 is 3. and then the numerator becomes just 20 square root of 3, and there's nothing you can do from there. So then that's it. That's what x is. X, therefore, again, it's the length of the smallest side. So this guy, I won't write it in because it's small, I don't have enough space here, but this guy here, y, is 20 square root of 3. Now the hypotenuse is twice that smallest side, right? So then you multiply this times 2, and if you multiply that times 2, you get 40 square root of 3 over 3. Finally, here I have a 30, 60, 90 triangle. I'm given the side opposite to the 60 degree, and again, I know that's going to be x square root of 3. Now this one, look at the way it's given to us. 9 square root of 3. Just by looking at it, if you know it's supposed to be x square root of 3, right? You know it's supposed to be x square root of 3, and they give it to you as 9 square root of 3. Well, look, just match it, and you know which one's your x. Your x is going to be 9. So then, opposite to the 30-degree angle, that's going to be 9. So that's where this guy comes from. And then finally, the hypotenuse is twice that small side, so 9 times 2, and you get 18. Okay, that's that. And that wraps up concept 39 for now.